Okay, pre-calc, we got one more lesson here I decided to do before spring break. And then when we come back from spring break, we'll jump back into all of these things with vectors. So today we're going to talk about operations with vectors, starting with multiplying by a scalar. That means a constant. Okay, a vector can be multiplied by a real number k called a scalar. This will change the magnitude of the vector. So we've got, let's say we've got this vector right here, vector v. If we multiply vector v by 2 and we get 2v, it is in the exact same direction, but it's just v times 2. So it's twice as long. If we multiplied v times a half, then it would be v in the exact same direction, but it's only half as long. And if we happen to multiply v times -1 to get negative v, then it's the exact same magnitude, but the direction is backwards. It goes in the opposite direction if you multiply by a negative number. Okay, that is multiplying by a scalar. Let's see what happens when we add two vectors. A geometric representation of the addition of two vectors, v and w, is shown to the right. Okay, so if you have two vectors, like let's say you have this vector v, and you have some vector w. I'm going to make w longer. Okay, to add the two vectors together, it's like moving one of them so that the tail of one corresponds with the tip of the other. So I'm going to take v or w and just move it up here. So now it looks like this. It's still the same magnitude, it's still the same direction. I just moved it up there so that it starts where v ends. And the addition of those two vectors is that side of the triangle. Okay, and the sum of the vectors, v plus w, is called the resultant vector. Okay, and it extends from the tail of v to the tip of w. All right, now let's look at subtracting. The difference of two vectors, v and w, is defined as v minus w or v plus. Okay, so this is adding. Let's look at subtracting. So now, instead of thinking of it as v minus w, we're going to think of it as v plus negative w, because we talked about what happens when it becomes negative. It goes in the opposite direction. So now, instead of, if we have our v, instead of putting our w goes in the opposite direction now, so it has to go like this, because this is negative w. So now our subtraction is this over here, v minus w. These are just like geometric representations of what these things look like. It's going to make a little more sense, I think, once we get into numbers. So let's look at down here. If v is a1, b1, and w is a2, b2. So this is in component form now. These vectors are in component form right here. Then for scalar multiplication, so if we wanted to say k times v, that's just going to be k times a1, k times b1. Pretty simple. Addition of v plus w, it's just going to be a1 plus a2, B1 plus B2. And subtraction is what you think it would be, and it's going to be A1 minus A2 and B1 minus B2. Right, so let's look at some with some actual numbers. We've got A equal to negative 6, 2, and B equal 1, 7, and C equals negative 4, 5. This is just adding, subtracting, multiplying. Okay, number 1. 2C is going to equal 2 times negative 4, 2 times 5, which equals negative 8, 10. Pretty straightforward. Number 2, A plus B equals negative 6 plus 1, 2 plus 7, which equals negative 5, 9. Number 3, C minus B is negative 4 minus 1, 5 minus 7, which is negative 5, negative 2. And number 4, okay, this one's a little more complicated. A minus 3C. So that's going to be A, which is negative 6, minus 3 times the C, or 2 minus 3 times C. So that's equaled to 6, negative 13. Okay, those are fairly simple operations with vectors. Multiplying by a scalar. Oh, there's more on the next page. Let's do the last ones. Number 5, 1/2 A minus B is going to be 1/2 of A minus B, 1/2 of A minus B. So that is negative 3 minus 1, that's negative 4, and this is 1 minus 7, negative 6. So that's number 5. And number 6 is 4B plus 5A, and that is 4 times 1 plus 5 times negative 6, and 4 times 7 plus 5 times 2. So if you do the math there, this is going to be negative 30 minus 4, so negative 26. And this is going to be 28 plus 10, 38. So those are the answers for those. All right. Those are rather simple operations, adding, subtracting, and multiplying by a scalar for vectors. So let's talk about what a unit vector is. A unit vector is what you might think it is. A unit circle has a radius of 1. A unit vector has a magnitude of 1. Okay, it's called a unit vector. So given any non-zero vector, so it can't be 0, 0, just a dot, a unit vector u, okay, so if we have a non-zero vector v, a unit vector u in the same direction of v can be written as 1 over the magnitude of v times v. That's how you find the unit vector that is associated with the vector. So let's look at an example. We got v equal negative 5, 12. It says find the unit vector u with the same direction as the given vector. We're going to have to find the magnitude. So that's going to be the square root of 25 plus 144. And if you do that, that actually equals 13. So now our unit vector equals 1 over 13 times our vector. So that equals -5/13 and 12/13. So what this is doing right here, let me erase this so I can write a graph over here. Okay, our original vector was -5, 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12. So our original vector looked like this. And our unit vector, and the magnitude of this vector is 13. We found it right there. It's 13. If we wanted to write a vector in this very same direction that is only 1, then the point that we would use right here is -5/13, 12/13 to get that point. A vector that is exactly the same direction and everything, but only has a magnitude of 1. So let's look at number 8. We've got n equals 9, 12, or 9, 12. So to find the unit vector, let's find the magnitude. So 9 squared plus 12 squared, and that equals 15. So the unit vector associated with this vector is 1/15 times 9, 12, which is 9/15, 12/15, or 3/5, 4/5. Okay, 3/5, 4/5 is our unit vector. Let's look at number 9. P equals -4, -1. Finding the magnitude, we've got 16 plus 1. Oh, now our magnitude is the square root of 17. That's fun. So our unit vector is 1 over the square root of 17 times this, which equals -4/7 square root of 17, -1 over the square root of 17. But of course, we like to rationalize our denominators. So this would be -4 over the square root of 17 over 17, negative square root of 17 over 17, with our denominators rationalized. Number 10, K equals 16, -8. Finding the magnitude, that is going to be 8 times the square root of 15. Okay, you can go ahead and find that. Our unit vector is 1/8 times the square root of 15 times 16, -8. So this is 16/8 times the square root of 15, -8/8 times the square root of 15. So there's lots of simplifying that we need to do here. First of all, 8 can go into there, so this could be 2 over the square root of 15, and this could be -1 over the square root of 15, and then rationalizing the denominator, 2 times the square root of 15 over 15, and negative square root of 15 over 15. Okay, that was number 10. Let's look at number 11. Oh, number 11 doesn't even give us the component form. We actually have to find it before we can find the unit vector. So we have 2 points. And we first have to find the component form of AB. And remember that it has to be terminal minus initial. So 6 minus 0. And -1 minus -7. So the component form is 6, 6. And our magnitude is square root of 6 squared plus 6 squared equals square root of 72, which equals 6 times the square root of 2. So our unit vector is 1/6 times the square root of 2 times 6, 6. which equals 1 over the square root of 2, 1 over the square root of 2, or square root of 2 over 2, square root of 2 over 2. And the last one, number 12, is the same. We've got P is -1, 4, and Q is 8, -2. Finding the vector in component form, 8 minus -1, -2 minus 4. Remember, you have to go in that order. So this is going to be 9, -6. Finding the magnitude, that equals the square root of 117, which is 3 times the square root of 13. So our unit vector is 1 over 3 times the square root of 13 times 9, -6. I'm going to do this all in one step here. The 3 goes into 9 3 times, and 3 goes into -6, -2 times. And rationalizing the denominator, we get 3 times the square root of 13 over 13, and -2 times the square root of 13 over 13. And that is our answer for number 12. So those are unit vectors, and how you find unit vectors given any vector. So let's look at the next page. And we're going to talk about standard unit vectors. Okay, the standard unit vectors are going to be called I and J. This is not I as in the imaginary number I. This is a vector I, and they are positioned along the X and Y axis, and they're defined as I is 1, 0, and J is 0, 1. So if you look at this, 1, 0 is right here. So here's I, and 0, 1 is right here. So there's J. So J is like the Y, and I is like the X. So any vector V, which is, any vector V, which is defined as AB, can be written in the form AI plus BJ. This is called a linear combination of vectors I and J. Okay, I and J are special vectors. They're standard unit vectors, and we can write any vector as a linear combination of I and J by writing it as AI plus BJ. Okay, here's your steps. Given a vector AB, rewrite as the sum of two vectors. So step 1, rewrite as the sum of two vectors. So we're given V is AB. Step 1, we're going to write V as A0 plus 0B. You can see how we can divide it up like that. Because if we added these together, we'd have A plus 0, 0 plus B, and we'd end up with AB. Step 2, we're going to factor A and B out. So now we're going to write this, because A and B are just numbers, as A times 1, 0, plus B times 0, 1. And then step 3, we're going to substitute I and J for the unit vectors. Because look, this right here is our unit vector I, and this right here is our unit vector J. So we can rewrite this as AI plus BJ. That was just kind of like a little proof to show you how you can do that. Okay, so number 1, rewrite each vector as a linear combination of I and J. It's way easier than doing all of those steps. If it's already written in component form, we're going to write it as 2I plus 5J. And number 2, we're going to write it n as negative 7i plus 3j. Okay, pretty easy. Number 3, you got to write it in component form first. So we first have to write our, we first have to write our s, and that's going to be negative 5 minus negative 9, terminal minus initial, negative 6 minus 8. So that becomes 4, negative 14. And now we'll go the next step to write it as a linear combination of 4i minus 14j. And for number 4, writing it in component form, PQ becomes negative 2 minus negative 10, that's an 8. 5 minus 6 is negative 1. Writing it as a linear combination, 8i minus j. All right, trigonometric forms of a unit vector. You knew we were going to get back to trig. If u is a unit vector, then so u is a unit vector. Remember what that meant? That meant that it has a magnitude of 1. Then the terminal point of u lies on, the unit circle, because the unit circle has a radius of 1. So this vector, if it has a length of 1, it's going to lie on the unit circle. So looking at the little picture over here, we've got our unit circle, and we've got a vector u. Okay, and here's our I. Oh dear. I erased it all. I don't know how I did that. I'll start over. Here's our unit circle. Here's our vector u. Here's I. Here's j. Okay, therefore u, u is AB right here. It can be written as cosine theta sine theta, or as the linear combination of cosine theta I plus sine theta j. Okay, here's our theta right there. Because every vector v is the product of its magnitude and its corresponding unit vector, okay, so think of that for a minute. Every vector v, this is the formula that we used to find the unit vector. So every vector v is the product, we could rewrite this, every vector v is the product of its unit vector and its magnitude. That's just this formula rewritten. Because of that, we can rewrite v in the following form. So v equals the magnitude, its magnitude times its unit vector, which equals its magnitude times cosine theta sine theta, which we could rewrite as the magnitude cosine theta, magnitude sine theta, or as a linear combination, magnitude cosine theta I plus magnitude sine theta j. All right, I know you loved all of that. So let's do some examples so we can see what this really means with numbers. So let's look at number 5. We've got vector v. Its magnitude is 8, and its theta is 60 degrees. Okay? So the directions say, find the component form of each vector with the given magnitude and direction angle. So using those formulas that I just had up here, v equals, well, I'm going to write it over here. V equals its magnitude cosine theta, magnitude sine theta. That was the formula that we just did. So in this case, V equals magnitude cosine 60, magnitude sine 60. And you know that 60 is on your unit circle, so you can find the exact form. Cosine of 60 is a half, sine 60 is square root of 3 over 2. So it's 4 times the square root of 3. And that's our answer for number 5. Okay, number 6. We're given that the magnitude is 20 and our angle is 225. Again, this is on your unit circle. So W is going to equal 20 cosine of 225, 20 sine of 225, and you're going to look on your unit circle and find what that is. And that's going to be negative square root of 2 over 2 and negative square root of 2 over 2. So that equals negative 10 times the square root of 2, negative 10 times the square root of 2. And that's our answer. All right, let's look at number 7. Our magnitude is 12 and our angle is 150. So our vector is going to be 12 cosine of 150, 12 sine of 150, which equals 12 times negative square root of 3 over 2, 12 times a half, which equals negative 6 times the square root of 3, 6. Okay, all of those examples, your angle was on your unit circle. Number 8, your angle is not on your unit circle. So what are you going to do? It's an A. You're going to have to use your calculator. And you're going to say A equals 30 cosine of 340, 30 sine of 340. And you're just going to put that all in your calculator and you're going to get 28.19, negative 10. Ugh. Why does it keep doing that? I'm sorry. Number 8, the answer is 28.19, negative 10.26. So see if you can get that. Okay, these last problems here, 6 more problems. Write each vector in trigonometric form. So number 9, we've got a vector and we want to write it in trigonometric form. We've got to have our angle and we've got to have our magnitude in order to do that. So our magnitude is 17 in this case. Go ahead and do the figuring for that. And remember how you do your angle. Tangent theta equals 8 over 15. So you're going to put that in your calculator. What quadrant is 15/8 in? It's in the first quadrant, so you can just take the angle that it gives you, that your calculator gives you, which is 28.07. So to put this in trigonometric form, we say V equals 17 cosine of 28.07, 17 sine of 28.07. And that is the answer. That's all we're doing right here. Or if you wanted to write it as a linear combination, you could write it as 17 cosine 28.07 I plus 17 sine of 28.07 J. Okay? Well, no, let's not write it as a linear combination. You could factor the 17 out if you wanted, but we're just going to leave it like this. Okay, number 10. We've got m equal to -3 times the square root of 2, negative square root of 6. All right, first thing we got to do is find the magnitude. Okay, what's 3 times the square root of 2 times 3 times the square root of 2? That's 9. Okay, it's going to be positive, even though this is negative, because it'll be 2 negatives. So 3 times 3 is 9. Square root of 2 times square root of 2 is 2. So that's 18 plus 6, which equals square root of 24, which is 2 times the square root of 6. Okay, there's the magnitude. Now we got to find the angle, tangent theta. What quadrant is this in? Negative, negative. This is quadrant 3. So tangent theta equals negative the square root of 6 over negative 3 times the square root of 2. You can just put that right in your calculator and you get you get 49.11. But 49.11 is not in quadrant 3. So what do we have to do? We have to add 180 to get it into quadrant 3. And our angle is 229.11 degrees. All right, I did something wrong. What did I do wrong? This is an actual angle on our unit circle. So this, I put something in my calculator wrong. Because if you do this, you should get 30 degrees, but 30 degrees is not in quadrant 3, so you have to add 180 and you get 210. So you could notice that if you simplified this, it simplifies to the square root of 3 over 3, and know that that is one on your unit circle, and you could have just found this from your unit circle, or you can put it in your calculator. I don't really care. Anyway, your trigonometric form is going to be 2 times the square root of 6 cosine 210, 2 times the square root of 6 sine of 210. Basically, we're looking for magnitude and theta right here. That's number 10. Let's look at number 11. P equals negative I plus 7J. So this is in linear combination form, but that's okay. You know that that just means -1, 7. So our magnitude is square root of 1 plus 49, or square root of 50, which equals 5 times the square root of 2. And our tangent, theta, is 7 over -1, or -7. What quadrant is this in? This is in quadrant 2. So if you put this in your calculator, you get theta equals negative 81.87. But we don't want negative, so we're going to add 180, and you get theta equals 98.13. And P equals 5 times the square root of 2 cosine of 98.13, 5 times the square root of 2 sine of 98.13. All right, I'm just going to finish these. You can do however many you think you need. Number 12, negative 2i plus 2j. The magnitude is going to be 4 plus 4, which is the square root of 8, which is 2 times the square root of 2. Tangent theta equals 2 over negative 2, which is negative 1. This is in quadrant 2, so where you should, this should be a clue to you that this is an angle on your unit circle. If you look on your unit circle, theta equals 135. And r is 2 times the square root of 2 cosine 135, 2 times the square root of 2 sine of 135. Number 13. Oh, I'm going to get a new page for this because we have to actually, we have 2 points and we have to find the vector first. So to do that, we're going to do negative 9 minus negative 1, which is negative 8, and 3 minus 7, which is negative 4. So now we can find the magnitude, which is 64 plus 16, which is the square root of 80, which is 4 times the square root of 5. Tangent theta is negative 4 over negative 8, which is 1/2. Okay, this is in quadrant 3, and you can put this in your calculator. You don't have that in your on your unit circle, and you get 26.57, but that is not in quadrant 3, so we have to add 180, and we get theta is 206. Whoa. Theta is 206.57 or 56, depending on how you rounded it. And we can write our vector as 4 times the square root of 5 cosine of 206.57, 4 times the square root of 5 sine of 206.57. And finally, the very last one, we're going to write our component form. And so we're going to do 5 minus 3, which is 2, and negative 8 minus negative 2, which is negative 6. And find the, this is YZ, find the magnitude, which is going to be 4 plus 36, which is the square root of 40, which is 2 times the square root of 10. Our theta, what quadrant? This is quadrant 4. Our theta is going to be negative 6 over 2, which is negative 3. Doing that on your calculator, you get theta is negative 71.57, but we don't want that, so we're going to add 360. This is the one where we add 360, and we get theta is 288.43. And our vector is this. Okay, so I'm going to give you some homework for this. That will be due on Thursday before spring break, and then when we come back from spring break, we'll come back in these vector things.